Okay, so we've told you not to use a calculator this week, and when you're told not to use a calculator and you're evaluating a logarithm, then you should be thinking this must be a power. The number that's inside the logarithm must be a power of this base in some way. So you want to try to rewrite this as a power of the base. So I'm gonna rewrite this as 16 is equal to 4 squared. So log base 4 of 4 squared. Well, that equals 2, right? Because remember, 4 raised to the 2 equals 4 squared. So this number, log base 4 of 16, is equal to 2. So like you could go and say, I would like to order log base 4 of 16, I don't know, sandwiches. And that just means 2. It's a number. These are numbers. So log base 7 of 49. 49 is 7 squared. So that's also the number 2. This expression is equal to the number 2. Log base 100 of 10. So what we're looking at here is we need to write 10 as a power of 100. So let's think about that. 10 is equal to the square root of 100. So that means 10 is equal to 100 to the 1/2. So I'm going to rewrite this as log base 100 of 100 to the 1/2 because the square root of 100 is 10. And anytime I have a base and then that base raised to a power is inside the log, the answer is just that power. Because remember, 100 raised to the 1/2 equals 100 to the 1/2. What about this one here? So what's 1 over 216? So if I go over and I say, oops, sorry, I was off here. If I do 1 over 216, well, 216, think about it. You know that this has to be a power of 6 if we've asked you to do without a calculator. So let's just think 6 times 6 is 36, right? So 6 times 6 is that. Now if I multiply that by 6 again, I get 36, 18, 216. So 36 is 6 squared, 216 is 6 cubed. So that equals 1 over 6 cubed, but I don't want it as a 1 over 6 as the base. I want it to be a base of 6, so that's the same as 6 to the negative 3. So this equals log base 6 of 6 to the negative 3, and that equals negative 3. Next one, 1 over 100, and this is a base 10, right? So I'm going to say 1 over 100 is equal to 1 over 10 squared, because I'm looking for a base 10, and that equals 10 to the minus 2. So this is the same as log of 10 to the minus 2, because 1 over 100 is 10 to the minus 2, and so this is going to equal negative 2. Next one, log base 4 of 1024. So I want you to think about that. 1024 came up earlier, and I just want to do a little mental exercise on this one. So if we know that 1024 is 2 to the 10th, we did that in the one of the last videos. So let's think about that. 2 to the 10th, that's 2 times 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 2, right? That's 2 to the 10th. There's a 4, a 4, a 4, a 4, a 4. So 2 to the 10th is equal to 4 to the 5th. But you know that because 4 to the 5th is 2 squared to the 5th, which is 2 to the 10th. So you know that from your exponent work, right? And so we can say that this is equal to log base 4 of 4 to the 5th, and so that equals 5. Anything to the any log of 1 is equal to 0 because log base 7, 1 is equal to 7 to the 0. And so that equals 0. And log base 2 of 32, so log base 2, 32 is 2 to the 5th, 2, 4, 8, 16, 32, 2 to the 5th, so that's equal to 5. Okay, the next part says expand these logarithms. So anytime you have a product inside the log function, you can separate them into separate logs by addition. So log base 3 of 3 plus log base 3 of x plus log base 3 of y squared plus log base 3 of z to the 5th. And now we have to finish it. Log base 3 of 3, well, that's equal to 1, plus log base 3 of x. When I have a power, the power comes out front, so we get plus 2 log base 3 of y, plus power comes out front, 5 log base 3 of z. Okay, I'm going to do 66 down below to give us some more room. So we have log base 4 of 4w over x squared. It's a division, so we're going to do a subtraction. So we have log base 4 of 4w minus log base 4 of x squared. This is a product, so I can separate it. Log base 4 of 4 plus log base 4 of w minus this 2 is a power, so it comes out front, 2 log base 4 of x. Now log base 4 of 4 is just 1, so I have log 1 plus log 4 of w minus 2 log base 4 of x. Okay, we'll come back and we'll do 67. So we have log base 5 of 1 minus log, and I put this in parentheses because I have several things in here, log base 5 of c squared d to the 5th. And now I'm going to separate that. So I have log base 5 of 1, and I'll come back and clean that up in a minute. Log base 5 of 1. Let me just sort of separate these out. Okay, and then we have minus log base 5, and I have to put this in parentheses, of c squared plus log base 5 of d to the 5th. Right, so I put them in parentheses because this minus now gets distributed to both. The 2 comes in front of the log base 5 of c, and the 5 comes in front of the log base 5 of d. Now, what is log base 5 of 1? That's just 0. Minus 2 log base 5 of c minus 5 log base 5 of d. And technically, I don't need the 0. The answer would just be minus 2 log 5 base 5 of c minus 5 log 5 of d. And I didn't fit 68 on this, so let me just do 68 down. I'll do it on the back of this. So 68 is log base 8 of 8m to the 4th divided by u squared v to the cubed. Okay, so if we separate this, we have log base 8 of 8m to the 4th minus log base 8 of u squared v cubed. So I'm going to put that 3 out front first. You could do it either way. You could distribute it into these separate powers. This first one's going to separate to log base 8 of 8 plus log base 8 of m to the 4th minus 3 times, and I'll put log base 8 of u squared v. And then if I continue, log base 8 of 8 is 1 plus log base 4, putting the 4 out front, log base 8 of m minus 3 times log base 8 of u squared plus log base 8 of v. That 2 is going to come out front, and then when I distribute your 3 in, right, so I'm going to put the 2 here, cross it out. So when I multiply the 3 in and distribute it, I get a minus 6 here and a minus 3. So my answer is 1 plus 4 log base 8 of m minus 6 log base 8 of u plus, minus, because I distribute that minus 3 in, minus 3 log base 8 of v. Okay? And there's a couple more problems on the next page that are putting logs back together, and I'll do those in a separate video.